When you are packaging something with a fixed minimum weight, but of course you do have some spread in your process, what's better? To make it a bit heavier so that you do not have any products that are too light, but you give away a bit more product, or to scrap a couple of those products but make sure that you are very close on target? Let's find out. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today's video is a bit of an optimization problem, but it really is about if you have a product with a fixed weight and you have to choose how much extra to put in each package to make sure that you spend the least amount. What are the factors that you look out for? And for that, it's important to know each process will have a certain spread. Now, as Six Sigma professionals, we always try to reduce that spread, make our process more stable, but in any case, on the short term, we will have a spread that from today till tomorrow will not be changed. So while we have this spread, it is also good to know where should we center our process. And especially when we're talking about giving away more material, so more kilograms of product, or accepting a bit higher scrap rate, because we do have a check weigher at the end of the line if the product is too light and gets kicked out, and we'll have to pay for it. There is a loss here, but we also have to pay for adding more material to our product. You might think that a customer doesn't mind getting a little bit more, and this is usually the case, but they're also not paying you for it. So you are giving away extra product, and if you do this too much, it can really wrap up the bill for you. So how to check this? And for that, we need to know this here costs us money. So this whole area here is all more than our minimum weight. Everything here is costing us money. And the farther that we move away, the more money it will cost. This money will be our material only. Now, the other side of our equation also costs us money. And here we get into our balance, because this here is our scrap cost. It will cost the full production cost of our product minus what we get back. And that is an important thing because it really differs between industries. So the COGS minus the sales, or perhaps we should say scrap value. And when you are bottling water, basically your material doesn't cost a whole lot. There is relatively a lot of cost going into the packaging machine, the packaging itself. You will not get these costs back. So you will have relatively high cost of your goods sold, or your production cost compared to material. There is basically no scrap value. So when you are bottling water, just move the graph, center your process so that you are overfilling enough that you will never have any bottle that is underfilled and that you have to throw away. But when you are producing things from steel, but also when you are producing, for instance, butter, which is a very high material cost product, there is a very tiny margin for other conversion cost and sales price on top of it. Really, the material component runs way over half of the cost. In those cases, what you will also see is that those industries will make sure that you can still sell that scrap or rework it within your own factory, within your own organization, so that there is a relatively high sales value. Now, to take an example of this from a cheese factory, when you are slicing bits of cheese, what you will see is that the net scrap cost is only about €1, $1. And the material costs are roughly $3. So they are a lot more expensive. Because of course the COGS here are more than $3, but the scrap value is also more than 2. You almost get the material value back. And that makes that in such factories, steel, cheese, any expensive material factory, chocolate factories basically have the same, as long as you can melt back or rework in a different way your product and make new materials, there will be a very interesting balance. Now let's draw out this balance. So we take the amount of material and the cost. If we make our product heavier, what we will of course see is that there is a linear connection between how much heavier we make the product and how much we pay for the extra material. For making it lighter, so basically we start at the too light end and then making it heavier, the relationship will be the other way around. So if we make all of our product too light, we have to scrap everything, we have very high cost. But because of this S shape here, we also get an S shape there. And there is a sweet spot. So this is something that's very doable and very practical for your operators to check on a daily basis. So if you have a production organization where there is a relatively high scrap value and you see that the net scrap costs are lower than your material cost, really make sure that for the day-to-day optimizations you track this number. And in fact, what we did in our slicing factories is to make it a KPI for each operator, for the shift, for the day level. It doesn't have to go up to weekly, monthly. This is a real down-to-earth operational KPI. What was the total amount of money that we scrapped due to over-underweight added together with these factors that you will have to determine for your own product? And it became also a bit of a race for operators to make sure that they are at this optimum level. And like that, before you have a chance to really improve the process and make more money, you can at least optimize the current size that you put into your product and make sure that you follow this optimum or the minimum cost of the material on a daily basis. Really nice, and I have experience with it. It is easy enough to put this into practice on an hourly basis directly at the line. This will change the way that your operators think about the material that goes into the end product, and they will also see that sometimes putting a bit more material in the product is good for scrap rate, or the other way around. They will understand that sometimes you have to scrap a couple of products to make the average of the batch come out in a better way. Really nice eye-opener when we introduced that at our factories. Now I hope that you like this way of looking at optimizing scrap versus giveaway. I'm sure there are plenty of products that I haven't mentioned but that do have this nice conundrum. Please put them down in the comments. I would be very interested to know in which industries this type of optimization is really a thing that is making a lot of money. Also, if you assume that maybe in your industry it could be a thing, but your company is not doing it yet, doubly let me know in the comments. And if you want a weekly dose of continuous improvement, Six Sigma, other things to increase your performance excellence, subscribe to my channel as well. For now, I wish you the best of luck optimizing your material flows, and of course, as always, enjoy your continuous improvement journey.